Okay, so it's my 4th hour class today, and this is Honors Pre-Calc, and we are doing a review for the Semester 1 final. And this is not comprehensive, it doesn't cover everything, but as opposed to not doing any review, I believe this will help jog some things in your memory and help them to set into your long-term memory. Some of these things we haven't touched in quite a while. All right, so some thoughts. You're going to be given on Friday of this week, you're going to be given a take-home portion of the final. That portion is meant to be something that you work on, including your notes. You can definitely use your notes on it, and you can work with other people, discuss concepts with them, and actually do problems with them. Now, is it okay for you to copy somebody else's paper? No, that is cheating, okay? And if somebody else is helping you with a problem, that is okay. Do you get the difference? You are going to have to sign a statement to this effect, that I understand everything I have written on this take-home final. And one more thought. If your take-home final comes in at an A because you just copied Billy Smarty Pants, and then you do the rest of the final and you get a D, I'm going to know what happened. Okay? And I do reserve the right, using my teacher discretion, to lower your grade on the take-home portion of the final if that happens. Because there's no way you're going to get an A on the take-home portion of the final and then get a D on the rest of the final unless you just copied somebody else. That increases your importance of actually learning what you are doing on your take-home final. No reason to cheat on that. It's just going to look really bad later when I look at your other scores and go, gee, got a straight A here, got a D there. All right, so anyway, bottom line, do your own work, but you can work with somebody else. Somebody explains how to do a problem to you, that's an okay thing, as long as you understand how to do that problem when you write it down. All right, so that'll be handed out on Friday, and I want to go through a bunch of concepts that we haven't talked about for a long time. One of the major topics that we had was logs, so I want to start with that. So I'm going to give you a log question, see if this rings a bell. Let's say that you had the log of, let me see here, 2xy over 7. That is one log, and it's got a base that isn't written. What's the base then? Base 10. Do you remember how you can expand that and make it into multiple logs? Log of this, and log of that, and log of that. Write for me the expanded. And it's, in fact, they would usually say expand and simplify. And I'm going to change one little thing. The 7, I'm going to make that a 10. Everybody do a little forgery and change that 7 to a 10. So the question is, expand and simplify. I'm going to give you a second to give that one a shot. Okay, let's see if you did this one right. So, log, and first I'm going to just do the top. Do you get that that's a 2 times x times y? And therefore I can break it into log 2 plus log x plus log y. And my advice to you has been, if you aren't writing, if you're given a problem that doesn't have the base, that you should write the base in, because you'll start to notice things sometimes. In this case, none of these really matter that you wrote the base in, because it didn't like match up with this. Hint, hint, on the other one, right? Did you notice that that base matched up on the other one? All right, so then this is my beginning, and then it says divided by 10. So that's minus log base 10 of 10. How many of you noticed that that needed to be simplified to a 1? Okay, if you didn't do that, you just lost the point. That will be expand and simplify are the directions. That has to be expanded all the way. Okay, could I have, let's say I had a squared in the problem right there, and this has therefore a squared on it right there. Then wouldn't you have to do something with that too? Put it down in front, like that. Okay, all right, so that's expand. How about condense? Well, let's say you had a big one like this, 2 log e. Now that's not log base e, it's just log base 10 of e. 2 log e plus 3 log y minus log 7. Condense that one down. Pause where you try. Right. So on this one, we were condensing it down to one log. First thing, I think of this as like unpacked, and then I got to pack it back up and put it away. Do you get that this 2 gets to go back up onto the E? Raise your hand if you did that. Okay, good. And this 3 goes up onto the Y, and that's about it for that. So now I can put the plus together into a multiply. Log E squared times Y to the third. And then the minus there means divide. So divided by, do I have to do the whole thing divided by? No, then I'd have to have a whole nother log on the bottom, and we want this to be one log. So it's just that part gets divided by 7. If you had 2 logs in your answer, you didn't condense it all down into one log, and that's the directions. Yes? Yep. Here, that is all right there. That all is the argument of this problem. If you wanted to know what the base was, I did suggest in the past that writing the base in is a good idea. There we go. Base 10. Okay, that's expanding and condensing logs. How about solving logs? Well, the reason we have logs in the first place is to solve things like this. Now, granted, I've taught you already that you can just graph both sides and see where they cross. You don't really have to. Now, in the old days, they didn't have graphing calculators, so that was not a practical thing. Okay, but for you with a graphing calculator, you can just graph both sides and see where they cross. But you could also use logs to solve it. So, would you please do a rewrite? That's one of the most critical skills, is being able to rewrite this as a log. Everybody try that. And I'd like you to compare with the person that is sitting directly across from you. I'm going to pause for a second while I make some groups of the people. Okay, did you get log base 5 of 10 is x? Raise your hand if you had that right. Okay, good. And that jumps over there and over there again. When you're doing a rewrite, it has to jump back and forth. Same thing happens if I had said log base x of 5 equals 2. You have to jump around to get it rewritten. Start here, though, and it'll be the base of your exponential. Everybody rewrite that as an exponential. I'll pause while you try that. Okay, should have said x to the second equals 5. Am I done? No, because x isn't alone. If the point is, rewrite is what I told you to do. But why do we do this? Because we want the x alone. So let's get x alone. How do you get that 2 off of there? You unsquare it with the what? Square root. 1/2 power is the same as square root. There, now x is alone. But did anybody notice that I just did a square root on both sides and therefore need a plus and a minus on my answer? But then, did anybody notice that the plus and minus doesn't actually work in this case? Because why? Because you can't have a negative in the base. So even though that's extra smart to have remembered that it's a plus and minus answer, you got to cross off the negative part of it because it can't be negative because of the rules for logs. Let's go over those rules. Let's say you had log A, B equals C. We have rules about A and B. C can be anything. Okay, there's rules about A and B, though. A has to be positive and therefore can't be 0. B has to be positive and can't be 0. Exactly. Which one can't be 1? A can't be 1. B can be 1, and if you've done that, you have won the argument. There you go. If you win the argument, you get nothing. Also true in life, especially when arguing with your parents. Okay, so, or your wife, yes, or husband, or whatever. Okay, so the C has to be 0 in this case, because if you won the argument, you get nothing. And if you rewrite it, A to the C has to equal 1, right? And what's the only way that's going to work? If C is what? C is 0. Okay, so here's some other rules about logs. Log base 3 of 3 to the 5th. What's the answer? 5. Because if these two are the same, the power is the answer. Only a couple people answered, so that makes me nervous. What's this one? Log base 2 of 16. Think for a second. Don't say it out loud. Think. Raise your hand and with the answer on it. with your answer on your hand? Ah, there it is. 4. Lots of 4s. Very good. Because 16 is really 2 to the 4th, and therefore the answer is 4. Okay. Next thing about logs is that e ln 5 should be telling you an answer. E to the power of ln 5. What did I say about it when they don't have bases shown? What should you do? Write it in. So it's log base e. And now you notice that and that are the same, so that's the answer. Okay, what if it was 7? Log base 7 of 15. What's the answer? 15. If the bases are the same, that's the answer. Okay, another little pattern. Let's say we have log 100 to the negative third. Now, that one doesn't just jump right out at you. But do you get, what is the base here? 10. Do you get, you could probably rewrite that as a 10 to a power. And if you could, you'd have the answer. So another way to get this would be to go, okay, equals x. There's no variable in it, so I can say equals x. And then I can rewrite it. 10 to the x equals 100 to the negative third. And if I could only get them to be written as the same base, then I'd be able to solve the problem. I made this one kind of hard, but yes?
So if you make log base 10 to the 10th, but then you multiply it with negative 3 after you subtract it.
All right, would you agree that this 100 could be written as 10 squared? Now, if I do that, does that remind you about those 2 and the negative 3? So what's the 2 and the negative 3 do? They multiply. If you have like 2 to the third to the 5th, that would be 2 to the 15th. That kind you multiply. Okay. It's this kind where you add 2 to the third plus 2 to the to the 8th. Then that's 2 to the 11th. No, it's not. I'm doing something wrong there. Hold on. Sorry. Sorry. Hold on. A to the second times, yes, a to the 7th. That's one where you would add them, for example. Okay. All right. Yes. What if it was plus? Then you couldn't actually add those because they're not like terms. So it only works if you're multiplying them. All right. Yes. Oh, bottom line is you have to show your work. So if you showed your work such that I could see what you did, and you rewrote that 100 as a 10 squared right there, then I would just expect that from there you would make some notation that this is the answer, and therefore 2 times negative 3 gives you your answer, which is negative 6, and therefore x equals negative 6. That's kind of sloppy work, but what I'm trying to say is show your work, and I'll be fine with however you want to show me. Okay, that's a quick explanation on logs. Let's move on to a different topic. Let's say we did a lot of stuff with functions and like f of g of x and g of f of x and all kinds of stuff like that. So let's say we have f of x is equal to 2x squared plus 2. Now, in this function, I'd like you to find me the x-intercept. Wait a minute, I should make this a little nicer. Hold on. I'm going to make this work a little nicer. Okay. I'd like you to find me the y-intercept. What would be a creative way for the teacher to ask you for the y-intercept? Yes? Yes, that's actually the zeros are called the x-intercepts, but the y-intercept is where what? X equals 0. So how could I write that? I'm going to have an f of x sort of, except f of 0. You get how that makes x equals 0? And therefore asking you that asks you for the what? The y-intercept. Okay. Go for it. It's really not too tough. Now, the x-intercept is where what? So I could ask you that by saying this. Get how I just said y equals 0 in a funny way? All right. Right stuff. I can remember it more. Then, if I had f of 2, that should be easy for you to do, I hope. And then here's one that's more complicated. F of x plus h. Do you remember doing that kind of thing? Take that and you stick it in for the x. You don't stick in x, you stick in x plus h. You don't stick in 2 like here, you stick in 2. Here you stick in x plus h. Why don't you answer those 4 for me, and I'll pause for a second while you give that a shot. All right, here we go. So you should have stuck in x is 0, so I'm sticking in a 0, and it makes that 0 and that 0, and it turns out to just be y equals 4. There you go. Y equals, that's an ugly 4, but it's a 4. Okay, on to f of x is 0. F of x is 0 means I put a 0 right here, and 0 equals all that. And I have a little saying for quadratics. If you can factor it, you should. Good. And if you can factor it, you should. This one can factor. Hopefully you factored it. Raise your hand if you did factor it. Okay, good. And I made it a baby one. I mean, you could make it a lot harder in pre-calc, but the moral of the story is you got to know how to factor. And my final answer would be x equals -1 and x equals -4. Okay, next one is f of 2. You stick a 2 into this function. And I end up with 2 squared is 4. 5 times 2 is 10. I think it comes up to 18. Is that correct? Okay, good. And the last one is f of x plus h. Well, you have an x plus h you put here, and an x plus h you put there. And you get x plus h squared plus 5x plus h plus 4. And that all adds up to, this one has to not be x squared and h squared. I hope you didn't fall into that trap. It's x plus h and x plus h, and then 5x plus 5h plus 4. And this would have to get FOILed out, so it'd be x squared plus 2xh, or hx, plus h squared plus 5x plus 5h plus 4. And then there's probably some more things that can get added together there. No? All not like terms? Okay, cool. Then that's your answer. All right. So that's another topic. I'm going to pause for a second while I get the next one ready. Okay, so here's the next one. This I had affectionately titled a Franken function, as in a Frankenstein, where the head is this and the body is that. Well, this is a function that's made up of 3 functions. Okay, and when you graph them, you have to like divide it up in parts, and like in here, this is an example one. Let's say it's an absolute value in here, and let's say it would have been a parabola, but you're only graphing it, the parabola part, in on the right-hand side, so you might have the parabola like rising over here, and then in this area over here, you might have just a line at, you know, x equal, or y equals -3 or something like that. So maybe it's a line that just goes up to here and then doesn't touch. That would be an example of a piecewise function. Do you get how then its equation would have been f of x up until, let's say this is at -2, and let's say this is at +3 over here for the x values. Then up until -2, it's just a line at y equals -2. Would you try to write me the equation that would go right here? And it's got this when x is less than or equal to -2, except that's not quite right. It's x is less than -2. So write me the equation that should go right there. If that line is right across from here, so let's say that's at -1. What you're doing is trying to write me the equation for this part right here. This is piecewise functions. Okay, so what equation does this thing like this? A straight line at -1. Is that x equals -1 or y equals -1? Y equals -1. So it's y equals -1 when x is less than -2. Okay, what's the next equation that I should put in this middle box? That's the one for right here. So try to figure out what equation is in the middle there. It's an absolute value function. Let's say it's not stretched. Let's just say it's a normal absolute value function. then try to write me the whole thing, both the function and the little domain part that says where that function should be graphed. Okay, so hopefully you said that that absolute value in there was y equals absolute value of x, because it hasn't been shifted up or down at all. I could have made it a little more complicated by just shifting it up 1 and then making you write like plus 1. You know what I'm saying? Okay, next is where is it that? It's that between -2 and 3. So let's go like this. And it's got a dotted line on both sides of it, so I'm going to kind of assume that it doesn't touch here. And I should be a little more clear with where it's touching. Actually, it would have to touch there because it doesn't touch down here. Well, technically, it could have a hole at the graph there, but I'm going to put a dot there, and I'm going to put a dot here. I apologize for not doing that, making it more clear that it does touch at both of those two spots. So then it would be less than or equal to and less than or equal to, if it touches at both ends. All right, then the last one is the green one, of course. But that one's a little bit complicated because it's hard to know exactly what stretch factor would be involved with this, but do you get, there'd be some equation here that's got a parabola in it, so maybe it's like got a stretch factor of 5 on the inside, which would be like 1/5 x squared. You get how that would make a, or wait, squared's got to be on the outside, sorry. You think it's got moved over also? I was intending that this be like a parabola that did something like that. Anyway, I don't expect you to know what this equation would be. I'm making it up. I'm just trying to show you. That's just a stretched out parabola. It would be, you can write the domain for it though. Try writing the domain for that. Then compare it with the person across from you that I have paired you with. I'll pause for a second while you try to write that domain. Good question. It can't be, because if it was touching right there, then it would fail the vertical line test. Get how there's a vertical line going right through that and it already touches on the other one? Okay, so there's got to be an empty spot there. I'll pause for a second while you compare with your partner. Okay, so here we go. You should have said that x had to be bigger than 3. Can it be equal to 3? No, because if it's at equal to, they both would own the 3, and that's not okay. This one already owns the 3 spot, and this one can't. All right, so x is greater than 3 is my answer. All right, so that is Franken functions, also known as piecewise functions. All right, next let's talk about its domains and ranges. So if I have a graph, we had a test like this where we had a picture that kind of went like this, and let's say this is at that's at the point -3, comma -2, and this is at the point right there where the point would have been at 5, 4. Then what's the domain and the range of this graph? I'll pause for a second while you give that a shot. All right, so you should have said the domain on this guy is this way, and the domain is from the x's, so it'd be from -3 to 5, and is there a bracket on one of them? Which one? Good, -3 to 5. And then for the range, that's this way, and that would be from the y, which is -2 on the low end, and it can be -2. To the high end is it would almost hit that high spot of 4, but it doesn't quite, so we put a parenthesis around it. Any questions on domain and range on that? Okay, now let's talk about domain and range in the context of a problem that has got this. What's the domain on this? All reals except what? 3. And what does 3 make in this equation? A whole. Very good. All right. And the resulting function after I cancel this off is just what? y equals x plus 3. That's a little graph that you could make very easily. But the graph, if you just graphed it this way and said, oh, it's x plus 3, so it's a y equals x graph shifted up 3. So it'd be kind of like, look like that. Why would this be a wrong answer? Because there's no hole. And this hole is supposed to be at 3. So you go over 3 spots, and thered be a hole right there. Okay, good. Yes? The y what? The y-intercept, do you mean? Yes. Then why don't you answer this question? The y-intercept is where? Oh, okay, okay. So hold on. Not the y-intercept of this graph, which would be right here, but just to clarify, the y-intercept would be where what? So you stick in a 0 right there, and you get y equals 3. So we know the y-intercept is 3. But the y-intercept of the hole, that hole is at 3 comma something. Would you agree with that? Because we know that x equals 3 causes the hole. Then what you do is you stick the 3 into the resultant function. The resultant function, the function that results after you canceled that off, is y equals x plus 3. So you tell me, when I stick this into that function, what do I get? When I stick this into that function, I get 6. So it must be a 3 comma 6. All right. Moving on. Let's see. We've done the Franken functions. We've done a lot of log stuff. Oh, rewrites. We did some rewrites, but we never did this kind of rewrite. Let's say that you had to solve this. 3 to the x equals 5 to the x. Say you had that. Do you remember, other than graph both sides and see where they cross, which would be wonderful if you had a graph calculator for everything, but you don't. You have a graph calculator for part of it. And you take home, granted, you're going to have access to a calculator, but all right, so how do I rewrite this puppy? All right, and if you want to, can you just slap a log in on both sides? Yep, can you use any base you want? And therefore, should you use some strategery? Yeah. And therefore, maybe use log base what? 3 or 5. I'm going to use log base 3. And I'm going to do that on both sides. And why is that any better? Because now I can slap this x down in front of this and get x log base 3 of 3. But I already know what log base 3 of 3 is. What is that? Log base 3 of 3 is 1. So therefore, x times 1 makes x. X equals, and now this side. Log base 3 of 5 to the x, it seems like, well, you still have an x in the exponent. But when it's written with a log, the x can go down in front. And I'll have x log base 3 of 5. Now, why is that any better? Because now I've got x's out of the exponent, and now I could solve it. You got to get all the x's to one side. So I'm going to subtract x from both sides, and I have 0 equals x log base 3 of 5. Yes, I can subtract x from both sides. What? This log right here? Yep, that is attached. It's attached with a multiply. So when I subtracted x, it just moved over to the end. See, I put a minus x at the end. Should I put it over there instead? That make it better? Okay. All right. All I did is subtract x from both sides. Now, can you factor the x out of this? If you can factor it, you should, right? So 0 equals x times log base 3 of 5 minus 1. Okay, I'm getting close. And then, okay, now that I got it factored like that, I can tell just by using logic, what's x got to be? 0. Okay, because 0 times what will make this 0? Well, 0 times anything will make it 0. That's just a number. So 0 times that number is the only way to make this equal 0. X has to equal 0. Or I could have divided both sides by log base 3 of 5 minus 1. And then that would have made it 0 divided by all that, which is 0. Kids get confused with 0 on the top versus 0 on the bottom. Is 0 on the top okay? Yes. Yes.
So all those types of equations,
yep.
The number isn't the same, isn't
I don't want to do another one. We're running out of time, but it is not always 0. And 0 can come up as an answer. And it makes it easy to see if you look back at the original problem. Do you get that 3 to the x is equal to 5 to the x if x is 0? Just like think about that. It makes sense. Okay, so if I made this something like 3 to the x plus, no, that's not good, 9 to the x plus 1, then my answer is not going to be 0, for example. Okay. So anyway, and on that one, you could, because I made the bases nice, I could rewrite this 9 as 3 squared, and then this would become 3 squared to the x plus 1, which now the bases are the same, so the exponents have to be equal. All right, a lot of things to know, and we're not going to cover it all today. Let me double check on when we're out of here. Pause for a second. So that's all I have for this part of the review for the final. We will do a little bit each day. Don't expect this all, all day tomorrow. We'll do a little bit each day, given that I need to cover a lot, and we have to hand the final out to you on Friday. So new stuff tomorrow. I hear some freshmen might be missing because of something. If so, then is that earlier in the day? Okay, good. So either way, I am doing new stuff tomorrow, so make sure you tune in the video if you missed that day.